Hello, this is Fahad and I'm with you again, and this time we're covering chapter 7, which is alternating current, power distribution and voltage system. So we'll go through the main key items in this. So we'll talk about first the difference between direct and alternating current. We did cover that slightly in chapter 3 and 4, but we'll go over it again, and how is alternating current is produced, the difference between single phase and three phase power distribution system. What does that mean? Again, we did get exposed to it a little bit, but I will try to highlight some of the major things again. So again, hello, okay, we're back, and this is video 2 for week 7, power distribution and AC and DC current. So we're talking about power distribution, and we said that DC current is not really practical for transmission over long distance, but this is how we started making electricity. In the beginning we used DC current, and we had to have a power station close to every house, so that was very unpractical. And if you look at your car does the same thing. It has a power distribution very close, within 10 feet of the source, so it's not going that far, because eventually it will get depleted, because we are always having resistance in the wires. So if this is my circuit, not necessarily bad one, okay. If I would like to, if I have a battery, this is my battery, plus and minus, and I have a very long wire. If I start here with 12 volts, depends on how long the wire is, eventually it will be like 11.8 in here. It will deplete over time. So that's the problem with having DC current. It is not really good for transmission. And so we also have the ability to raise or lower the voltage. That's another issue that we cannot have with alternating current, is like increasing or lowering the voltage, unless you have a transformer, and transformer does not really work very well with DC. And we will be required to use very large transmission equipment to be able to transmit power from one place to another. And that's why in the beginning, when we had the electricity war, eventually the AC current won the war for that case, and amongst many, which is transmission. Okay, so if we look at power generation, we always start with the power plant, which you have something around 120k to 220k volts. That's very huge. 40 substation usually transform that into 4080 and 4800 volts. That goes two ways. One will go through another transformer, which will transform the power to 120 and 240 for residential, and for commercial you can have more than 120, something between 240 and 480. That's for commercial use, because sometimes you will need to use big mills and big operating machinery that will require a lot of voltage. So this is one of the first kind of voltage we have. It's 240 volt single phase 60 Hertz system. If I were to write this in electrical notation, that will be 240 VAC dash 1 phase dash 60 HZ. This is how it will look like on the equipment, and exists in most residences. We say that every residential house has 240 volts. This is the most common one we see, and each leg has 120. So when we go into the control panel, you'll see two lines. Each one of them is 120 and 120 for each one of those lines. Two of them together are 240. They're very available in older structures, and they're used widely in Europe and sometimes in South America because they have more efficiency with some equipment. You will have lower amperage on the circuit if you have 240 volt voltage. And it is still possible to find single phase 2-wire system in many houses, and it's the most common voltage system mostly for residential. So that's 240 single phase 60 Hertz. That's what comes into your house, and you can take one leg with neutral. You're gonna have another neutral line here in, and that's going to be 120. If you take two hots, that's going to be 240. Okay. That's a single phase being taken from the control panel. This is, I think this represents circuit breaker or a fuse, and this is my neutral line. Back in the days, they used to use ground instead of neutral, and that worked, but now we need to have neutral line individually. Again, if you look at this schematic, this is what you have in your house. Two lines, 110, 110. Between the two lines you have 240 because two of them are hot, and the neutral is provided in the control panel, and that's that will make 120 between this hot leg and this hot leg. Okay, and this is how we go from a transformer in a substation into the house, making our wiring system. Again, that's not something you have to worry about, but it's good to know how is it configured. Three-phase voltage system. Again, three-phase is mostly for industrial or commercial buildings because it can operate big motors that will run huge compressors for air conditioner. So we have three hot legs and one ground, and it's more versatile. Why is it more versatile? Is because you can get one phase out of those two phases, and you can get 120, 240, and 400 out of those three phases. So if you have, for example, a factory or industrial equipment, you might need to have more than one. You want to have three phases with 420 voltage, so you can have different configuration of voltage based on the equipment you have. So advantages. Now that here we are talking about motors. If you have a motor with three phase, there is no need for starting apparatus because we looked before. There's three winding, and they are not symmetrical, which means that will allow the motor to run right when you put voltage to those windings. It's good for starting, and it has a good for starting the motor without like the need for capacitor. It has higher torque, higher power, and probably if you have a mill or big machinery, again, big laundromat, probably they have some equipment that will need three-phase motors to have this amount of torque. The disadvantage is the high installation cost and also the operation cost. They will require some more maintenance, and also you will pay for that power differently than what you will pay for residential. 240. So these are different configurations of how they are laid out. We do not need to know much about them. It's good to know the name. This one called a delta system. Again, it's one of the most common, but they differ a little bit. It's good to know those. Again, if you want to wire an AC, you want to see how they are wired, and when in doubt, you should call an electrician and see how do you get your own plug and your own connection to the AC. But again, it's good to have information about that. They are supplied in 4 wires, 3 hot legs and 1 neutral. And that's why sometimes you see different plugs for 3-phase equipment, different plugs for 240 equipment. It's based on the delta and the other system that I'll show you right now. So delta, probably you would have guessed, it looks like a triangle. That's called the delta system. And we'll see how. That's what it looks like. This is how you connect our delta system. You have 240 volt in between the L1 and L2. Between the 2 legs there are 120 between this leg and this leg, and 120 between those two. So if you go between the hot and hot here, you have 240. And again, you have another L1 coming in here with another I think this is substituting the neutral. So the connection L2 and L1 is different. Between the L1 and L2 there's 240 again, and this is a hot leg, L3, and L2 is here. And if we connect those two, hot and hot, in this configuration, you can get the 3 system. So this is how the transformer is hooked up for 240 volt 3-phase 60 system, and it's called the delta transformer. Again, we don't need to know, it's not gonna look exactly like that in real life, but this is how it's called and this is how it's laid out. Another system called the Y system, I'll talk about it shortly. But look, with this configuration here, the delta system, you can run 3-phase and 1-phase in the same time and having different voltage from the same source. So here you're running 240 and 240 with 1 phase, and here you're getting another phase with 240, and you can still have 3-phase over here. So it's a very nicely balanced system when you have this voltage, because you can use 1 phase and 1 phase and 2 phase as much as you want, and you can vary the voltage. You can have 140 and 240, 120 and 240 in the same time. This is another system called the Y system, and it is 208 volts. It's very interesting, and 60 Hertz. It's very common. You'll see it in school, hospitals, or office buildings. I haven't seen any so far, but probably in all those structures. And it's very versatile. It's very similar to what we have in the delta system, but it looks a little bit different, and it has different configurations. If we look here again, it looks like a Y. It's the Y system, and in this time we connected the neutral by itself in the middle. L2 is hot, and L3 is hot, and L2 is hot, and L1 is connected as its own leg over here. Again, it's called the Y system, different hookup, and they're all just done for flexibility and having more options. This is the Y system with 3-phase, delta and Y, and how they are connected to the main control panel. Again, it's not something you need to know that much, but again, look at the voltage RMS, which is root mean square, the average one, and the watts over here measured and controlled by the power factor. Y system connection, you can get 1 phase and 3 phase in the same time. Higher voltage, they're becoming more popular because again it gives you a lot of flexibility. They're using industrial and sometimes even residential, larger residential buildings. They have three-phase for better efficiency, and also the equipment runs in a smoother way with less trouble. And this is the amount of voltage you can have with three-phase. Again, that's something we don't have to worry too much about, but it's good to know what is the power supply to that house and how you're going to get the power for that piece of equipment. Advantage, don't worry too much. More connection. So another thing I want you to be mindful of is when you go and troubleshoot an equipment with three-phase, you need to know what power you should be receiving at each phase as we go. So let's say we have a problem in phase 2. The equipment is not going to run smoothly, so you can be having power in L3 and L1, but L2 is not giving you power. So that could be a problem. The main reason we need to know how those lines are connected and what power should I be getting in there is when I go with my multimeter, I want to know what power I'm getting between the two legs and why the system is not behaving the way it's supposed to. Okay, and yeah, so check the line voltage for each one of those legs. If you have three-phase, read the label on the equipment and make sure it's one phase or single phase, or whatever you have. So far we covered alternators, which they make the sine wave and the AC. Delta system is a way to connect three-phase system and get one phase out of it. Effective voltage is 0.707 multiplied by peak voltage, which is the top of the voltage here at 90. That's peak voltage. Frequency is the number of cycles in 1 second. Cycles per second. Power factor is the apparent power divided by the measured power, and that has to do with the effective voltage. Sine wave, this is a sine wave. Single phase and three phase in the Y system. Single phase, this is a single phase. Three phase, it's going to be right on top of it within small distance, which is what you have between the two circles, between go from this distance to here to here. That's the gap that you have. The Y system looks like a Y connection between L3, L1 and L2. That's the Y system. Okay, I hope this makes things a little bit clearer. Try to go over the PowerPoint and the book and let me know if you have any questions. Thank you.